So right now we are looking at the physics final exam open-ended questions that you guys are going to see. They're almost identical questions. They're going to be different, slightly different, definitely different numbers, but these are going to be the main concepts. All right. So question one is pretty much dealing with kinematic equations. You have four equations listed at the top. You have your four basic kinematic equations at the top. You have to look at the problem, break down what you're given. So in this, a fighter jet is catapulted off an aircraft carrier from rest, all right, to 120 meters per second. If the aircraft carrier deck is 75 meters long, what is the acceleration of the jet? Okay, so you have to read this and figure out, do I have a starting velocity, a final velocity? Am I accelerating? Am I at rest? Do I come to a stop? Or how far am I moving? All right, those are the things that you need to look at. Okay, so when they tell you they're starting from rest, that means your initial velocity, or you have an initial velocity, and it's zero because you're starting from rest. If they said, all right, if a problem says you come to a stop, then your VF, your final velocity, all right, would be zero. Now they said it goes from, I don't know if you guys have ever heard this saying, go from 0 to 60 in 2.5 seconds. Okay, that's like a miles per hour in a certain period of time. The acceleration for there would be miles per hour per second. All right, as your acceleration unit. Here we're looking at meters per second, and meters we're looking at, all right, for acceleration when the equation works out. Acceleration's got to make sure we're in the units of meters per second. So everything needs to be in units of meters per second. Time, seconds, and distance needs to be in meters. So if you have to do any conversions, you got to make sure you do so. All right, so we're going from rest. That means 0 to this. That will be our final velocity. So we have a final velocity of 120 meters per second. All right. The aircraft carrier deck is 75 meters long. What is the acceleration of the jet? So, all right, the jet's going from 0 up to 120, all right, over this distance where it takes off. So your distance here, or displacement, is 75 meters. They want you to find acceleration. So yeah, what do I do? Okay, I have four different equations. Look for the equation, all right, that has all of these. All right, all of these pieces of information. This one doesn't. All right, it has VF, VI, and A. Doesn't have distance, so I can't use that. Distance, VI, T. Well, I don't have T, so I can't use that. VI, VF, which I have. Distance, no A. All right, also T, which I don't have. This is the only one that you have right now that you can use. You have an initial velocity, a final velocity, a distance, and acceleration. So because of that, this will be the equation that you're going to use. So write the equation out. VF squared is equal to VI squared plus 2 times A times D. Okay, now what we're going to do, we're going to zoom it in, and we're going to put in our values. VF is 120. You have to make sure that that is squared due to the equation, equals 0 squared, which will cancel out. Bring down the plus sign. If this was a number, you'd actually have to sit there and work it out. All right, bring down the 2 because that's part of the actual equation. We don't know what A is, but we know that D is 75. All right, so now underneath that, how I want you to do this is to work everything out. So you're going to do 120 squared. And so when you throw that into your calculator, 120 squared, all right, 14,400. Okay, the 0 goes away. And now because you have this, you have 2 times A times 75, you can multiply these two together because it's like 2A, whatever. These two things will be multiplied. So you're going to do 2 times 75A. So 2 times 75 comes out to be 150, and you're left with that. And now isolate A. To get A, all right, by itself, you got to divide both sides by 150. Okay, that goes away. And then A is left as 14,400 divided by 150. And it comes out to be 96. And we would be looking at the units of meters per second squared. So you do need to memorize the acceleration unit. That unit is not necessarily given here, but that is a unit we've dealt with for a good portion of the semester. So please make sure that you do memorize that unit. All right, there you go. That's the first one. Now the next one, conservation of energy problem. Energy is neither created nor destroyed. It can only change form. All right. So mechanical energy is the sum of kinetic and potential. So I'm just doing a little side drawing here. Oh, if I knew that at the top of a drop, right? If I'm about to drop something off of the top of a desk, or I'm holding something and I'm about to drop it, okay, right there, I'm all potential energy. If it's not moving, kinetic energy is 0 because to be moving, all right, or if you're not moving, you have 0 kinetic energy because kinetic energy has velocity in there. And right as it would strike the ground, the potential energy at that point, gravitational potential energy, would be 0, and you would turn it basically all into kinetic energy. So if potential up here was 100 and this was 0, down here potential would be 0, kinetic would be 100. This is meeting somewhere in the middle. So what happens is as you fall, you're going to lose height. All right, mass times gravity times height. So the higher up something is, the more potential energy it has. As it's falling, as something falls down, it's losing its height, but what is it gaining as it falls? It's gaining velocity. So that, let's just hypothetically say, was 100 joules, somewhere in between, it could be 60-40, 50-50, 30-70. It's going to be a combination of that. So what we are doing in this is you're given the big equation here. The total energy, all right, initially is going to equal the total energy final. Okay, so how do we break that down? The mechanical energy is the kinetic energy initial plus the potential energy initial equals the kinetic energy final plus the potential energy final. And it breaks down into this long equation here because kinetic energy is 1/2 mv squared. They say VI because this is the initial. This would be the initial velocity. Now, the regular problem reads something with mass in there. I took the mass out because if we're talking about the same object, well, it has the same mass, so the mass doesn't change. So I took it out of that problem just to help you guys realize. We're going to scribble out the m's here. Because if it's the same object, the masses don't get affected, or they're not going to affect the overall answer. So now what you're going to do is you're literally going to put these values under what we have now. Okay, I have to bring down this 1/2. VI is 12, but the VI is squared, so you have to remember that. Put that inside the parenthesis. We're going to bring down your plus sign. Gravity for these problems that we're using. All right, what have we used for gravity? The true value is 9.8. The number that we've been using for gravity is what number? 10. All right, just makes the calculations a little nicer, a little easier. Okay, so 10 times initial height here of 36 equals 1/2 VF squared. We don't know what that is. Now, I'm going to show this because this had been something that, all right, when we were doing this the original time, this is, I'm just going to circle this. We're holding on to this. We're not changing anything here yet. We're going to keep this pretty much till the last two steps together. Bring down your plus sign. Gravity of 10. Final height, 6 meters. Okay, so now we have everything. Now you're going to, how I want you to do it is to simplify piece by piece. All right, what I would suggest is doing inside the parenthesis first. So 12 squared is 144. Then I'm going to divide that by 2. So this comes out to be 72 plus 10 times 36, 360 equals, again, I'm keeping this 1/2 VF squared together until the very end. Okay, bring down the plus sign. 10 times 6 is 60. So I'm going to now simplify the left side, add these two together, and I get, what did I get? 432 equals 1/2 VF squared plus 60. Now we need to get this by itself, so you got to subtract both sides by 60, so minus 60 minus 60. And that's going to leave you here with 372 on the left equals 1/2 VF squared. All right, we're trying to get VF. So we have to get rid of the 1/2. So to get rid of the 1/2 on the next to the VF, you have to multiply both sides by 2. So 372 times 2 comes out to be 744, and that leaves you with VF squared. And to get VF by itself, you then have to square root both sides, okay, and that will come out to be 27 point, you can call it, I don't know, 27.28. And that unit for velocity is meters per second. Okay, so you guys do need to know how to do the square root, all right, on these calculators. If you don't remember, okay, once you do the 372 times 2, all right, and you get your 744, right? So 372 times 2 gives you that. You're going to hit second. This x squared button shows the square root symbol. And then you can type in 744. If it's a long whatever number, you can hit second answer, right, which would be this little negative sign down here, which gives you your last answer from a calculation, and comes out to be that, rounded here to 2 decimals. Okay, so problem 1 that you're going to see is going to be one of these equations that is used. You have to figure out the information given, all right, initial velocity, final velocity, distance, time, and or acceleration, and then figure out the equation to use and solve. Here is going to be pretty much this exact problem, different set of numbers. Now the next one. This one combines Newton's second law. It combines balanced forces. It's talking about equilibrium. And we have a bunch of things kind of involved here, free body diagrams. So hopefully you guys remember that on a free body diagram, if something is sitting on a flat surface, all right, everything that has mass, all right, is under the influence of gravity, has weight, Fg, which is, all right, I wrote the equation over here, mass times gravity, we're using 10. If it's sitting on the ground, and not moving, like this pen is not falling down through the table, that means we have to have a force going upward. On a flat surface like that, we're calling that the normal force. So what we're going to do is first find Fg. You can take the mass times gravity. Mass of the object is given here as 50. So we're doing 50 times gravity of 10, and we're going to get 500. What is the unit for force? That you should remember, and if you didn't, it's right there, newtons. So we're going to put that here. All right, so you pretty much would get a point for showing the work here, a point for writing it down, another point for having this right here, the equal sign, just rewriting it up there, all right, because it wants a full, complete free body diagram with all the forces and all their values labeled. Cool, got it, right on. Now I'm not sure what to do. Right now I don't see an equation for FF. Well, that would tell you that's a hint. You're not necessarily going to use a separate equation for it. But what other equation is listed? All right, Fg. Fn wasn't listed, but the two equal signs should tell you that they're equal. All right, cool. The only other equation that's given is the net force. The net force is equal to mass times acceleration. We have mass and acceleration. So that's going to be something you're going to do next. So the net force on an object is pretty much the sum of all the forces. So it's the net force that causes the motion of the object, and it's going to cause, right, the direction to change. It's going to want to move in the direction of that net force. All right. So we have mass times acceleration. Mass, again, was 50. Acceleration is 3. Multiplying those out, what does that give me? 150 newtons. Now, what direction do you think the net force would be if we're just looking at the magnitude, all right, of these vectors? So the magnitude, again, stands for size. That's something else you want to remember for your final exam, okay? Looking at this, free body diagrams are, all right, these vectors are represented by arrows. The forces are represented by arrows that should be drawn in the direction of the force that they're talking about with a suitable scale, which means to a certain magnitude. So these two arrows appear to be equal in size, which would make sense because they're equal in magnitude, 500 and 500. Left and right are not equal in magnitude. It looks like the right side is bigger. So that would tell you that the direction of the net force would be what? Net force has got to be the dominant force. If the right side is bigger than the left, what would the direction of the net force be? It would be to the right. Okay, well, now it basically becomes this problem. If I know that this is the overall force, right, these two balance out. If I were to basically just draw a free body diagram of this object with only the net force, I would pretty much just see an arrow going to the right of 150 newtons. So what would friction have to be? For the net force to be 150 going to the right, that means the rightward force needs to be 150 bigger than the left. So what would the left have to be? There you go. It's a simple subtraction problem. All right. So FF will equal net force minus the applied force. I'm sorry, applied minus net. Oop. All right, so 200 minus your 150, and that is 50 newtons. So you would need to show pretty much this. You need to show, all right, mass times gravity in order to get the weight. All right, so a point over here, a point up to fill this in. A point over here to show the work to get your net force, and then pretty much the subtraction here to figure out that the friction force is 50. All right, so to complete that problem, that is going to need to be everything that is done and labeled on there. In these two conservation of momentum problems, you have an elastic and inelastic collision. The inelastic collision is where the objects stick together after they collide, which is represented by this equation here. This equation, guys, is pretty much just written, so you're going to put the values of everything underneath. Mass of the first object goes here. Velocity of the first object goes there. Mass of the second object, velocity of the second object. These two masses added together, and then we're looking for VF. So take everything and pretty much just write them out underneath. You have 10 times 9, bring down the plus sign. 12 times 0, because it's not moving, bring down 10 plus 12 times VF. So you're going to have 10 times 90, or I'm sorry, 10 times 9, which is 90. Bring this down. All right, this anything times 0 is 0. 10 plus 12 comes out to be 22, and now it's 22. All right, whatever the answer of this side in here, it's that times VF. So this is 22 VF. All right, 90. All right, if this was if they did give you a velocity here, if it's negative, you got to make sure you put in negative. Okay, if it was going to the left, we would say it. If it's positive, you do that, you would have to add. If it was negative, 90 plus whatever the negative is give you a different value here, and then bring this down. And to get VF by itself, you're going to divide both sides by 22. So 90 divided by 22. It's going to give us a value here of 4.09. And velocity is meters per second. And then the last one is a elastic collision. All right, you have two objects that are moving towards each other. They collide. After the collision, they're not stuck together. They've bounced off of each other. So we got to put everybody in the right positioning. Okay, mass of the first one, velocity of the first one, mass of the second one, velocity of the second one, mass of the first, new velocity, mass of the second, and we're looking for that V2. All right, so similar thing to what we just did, you're going to put all the values in underneath the variables that they have. So 5 times 7, bring down the plus sign. 12 times velocity of negative 15, equal sign. Mass of the first object again. If you need to draw the lines to help yourself, do that. All right, negative 20, bring down the plus sign. All right, and then God bless you, 12 times V2 prime, they call it. All right, V2 prime just stands for the velocity, all right, after the collision. All right, so we're going to go through this. 5 times 7 is 35. Bring down the plus sign. 12 times negative 15. This is a negative 180. Bring this down. 5 times negative 20. Negative 100. Bring down the plus sign. 12 V2 prime. When we were doing this, I saw this happen a bunch. If you need to circle this till the very end, do so. These are together. You can't add or subtract this 12. It has to be divided to get V2 by itself. Okay, I had people in the past go do this when we're simplifying, right? 35 plus a negative 180. Everyone seemed to do this side correct. But then I would get someone who would do this. They would do negative 100 plus 12, and on this side they would have negative 88 V2 prime and then divide. You can't do that. All right, mathematical operations do not allow that. So what we're going to do is we're going to rewrite all this stuff on the right side. Negative 100 plus this 12 V2 prime. Okay, to get V2 by itself, you're going to have to divide by 12. So let's get everybody that's not attached to V2 on the other side. All right, we want to get rid of this 100. Because it's negative, you got to add it to both sides. So this 145 plus 100 becomes 245. Then that is going to equal V2 prime. And now you can get this by itself. Divide both sides by 12. All right, and now 245 divided by 12 is going to give us an answer here of 24.4166666, repeating, so we'll call it 20.42. If we round it to 2 decimals, V2 or V2 prime, 20.42.
I don't think that's right.
Mr. Lombardo, I think I'm pretty sure 145 was negative.
Oh, hey, look at that. Glad you guys are actually paying attention then. Negative 145. Okay, so let's rework that. Didn't have my coffee. That is actually great. I'm glad you guys caught that. Thank you. All right, so negative 145 plus 100. This would become just negative 45 then? Which will change the answer up just a little bit. And that will equal 12 V2 prime. And then to get the 12 by itself, divide out both sides. Negative 45 divided by 12. Yep, that makes better. V2 prime becomes out to be a negative 3.75 meters per second. All right, good work. So that is that first part of what your final exam is going to be. All right. Make sure, all right, that you go through it carefully. All right. I was kind of trying to rush through it a little bit. And what I did, all right, is a very common mistake that can also happen. All right, so you just caught me in my mistake, which is awesome. Try not to make that same. Okay, this came out to be negative 145, negative 100. Okay, we had to add this to both sides. I forgot to drop this down, which would have definitely affected the answer. But showing the work, I would have been able to see where you went wrong. You would have gotten some partial credit for said problem. But just make sure that that is what we're doing. Okay, so again, your first problem is going to be a kinematic equation setup. You're going to be given information that can tell you whether or not you have a initial velocity, final velocity, distance, acceleration, or time. Figure out the equation to go or use, and then solve. Number 2 will absolutely pretty much be this exact problem with different numbers. So you will cross out the m's, all right, add in your given informations, all right, 1/2 VI, make sure that's squared, plus G, which you're going to need to know is 10 times 36 equals 1/2 VF squared, which is what we're looking for, plus gravity times the final height of 6. Okay, do the squared first, then divide it by 2, equals, got it, multiply, good, leave this be, good, multiply, good, add, simplify the left side, leave the right side kaput, get rid of whatever you need on this side by subtracting it, or adding it would have to be subtracted. We're not going to have a negative height. So you're going to, that works. And then you're going to have your left side is equal to 1/2 VF squared. You're going to multiply that both sides by 2. And then you're going to have that value is equal to VF squared. To get rid of the square, you have to square root both sides to get your final answer. And again, here, what you're going to do first, okay, do the equation. All right, for weight, add weight down, add normal force up, then solve for net force. No, that's pretty much going to be going in the right direction here because of the fact that the right vector arrow is larger. And then you're going to subtract, right? What would this need to be in order to make this true? Well, that means that this rightward force needs to be 150 greater than whatever this was. So 200 minus 150 gives us a 50 Newton force there. And as we just went through the collisions. All right.